Hello and welcome to the Angular Kinematics video tutorial. Here we have a bicycle wheel that is going to revolve around its center and move down the road. And we have some information about that bicycle wheel up here. And we need to determine the angular acceleration of the wheel and how far the center of the wheel travels during that time. The secret to angular kinematics is to realize that it's really not any different from linear kinematics. We're just going to have all angular terms instead of linear terms. So in a linear problem, we'd make a list, so we're going to make a list here too, and we have that ready to go. So here's our list. This is x naught, x, v naught, v, a, and t, just in their angular versions. The angular position, we're going to say just starts at 0 because that's a nice place to start. The final position, angular position, well, we're going to rotate 40 times. If we rotate one time, that would be 2 pi radians. So we just need 2 pi times 40. So 2 times pi times 40 gives 251.33 radians for our final angular position. Our starting angular velocity says it starts at rest, I believe, right there. So 0 radians per second. And our final angular velocity is 100 radians per second because it says so in the problem. We do not know the angular acceleration, and it's going to rotate for 3 seconds. So we had our kinematic equations, the v equals v naught plus at, x equals x naught plus v naught t plus 1 f at squared, and v squared equals v naught squared plus 2a delta x. We're just going to recreate those in angular form. So we're looking for this, and we have everything else, so we should probably use the v equals v naught plus at. So let's do that. So let's start with v. So there's v equals v naught plus at. So at. That's v naught, a, and t just in their angular form. So the angular velocity final is 100. And that's going to equal 0 plus, we do not know what a is. Whoops, don't want to do that. T is 3. Let's just put the 3 in front. So that's our time, 3 seconds. And so we're really just looking at 100 divided by 3. And I can do that in my head. Acceleration equals 33.3, repeating forever, radians per second squared. So pretty simple. There's our angular acceleration. Now to determine how far the wheel, the center of the wheel travels, the secret to this is to realize that whatever spot is touching the ground, the center of the wheel will be right above that spot always. So when this spot touches the ground, the center wheel is above that. When this spot ends up touching the ground, if it's rotating this way, then the center wheel will be above that. So actually, if we can just figure out how much of the wheel ends up touching the ground, we're going to get how much this went sideways. So what we really want is we want the circumference of the wheel, and it's going to rotate 40 times. So we want our circumference times 40, and that's going to give us how far the center of the wheel traveled. So our circumference is equal to 2 pi r. So 2 pi r. So that's going to be equal to 2 times 3.14, I'll write it out. 2 times 3.14 times the radius, which is 0.36, because we want to get this in meters. And that's going to be equal to, let's see, 2 times pi times 0.36 gives 2.26 meters. And that was the circumference, but we want 40 trips around. So the sideways distance x is going to be equal to 2.26 times 40. So times 40. And that's going to give 90.48 meters sideways. Thank you for watching the Angular Kinematics video tutorial.